Okay, so we're going to go ahead and start chapter two, just a little bit of chapter two. It's the pretty easy stuff. So 2.1 starts with the atom and what the atom is composed of. And so we know that an atom has a nucleus, right? The center of the atom is the nucleus. And the center of the atom has two things inside of it. It's very, very small, and it has two pretty massive things inside of it. And those are the protons and neutrons, right? And so anytime you see me, I'm going to absolutely abbreviate protons as P plus, and I'm going to abbreviate neutrons as N0. And the reason that I do that is because that tells me not only what subatomic particle it is, but what charge it is. So for that very first one, what are the subatomic particles located in an atom? So I'm going to say the protons and neutrons are in the nucleus. And that's really the center of the atom. Okay, now around that nucleus of the atom, there's a big thing called the electron cloud. And the electron cloud is just kind of an area. And it's an area, I'm kind of shading it all in, right? It's everything except for the nucleus that surrounds the nucleus, right? To a certain distance away from that nucleus in any given direction. And that is the electron cloud. So you have these little tiny electrons, and we'll call them, we'll put there's a little electron. So we're going to call this an electron, E minus. And so these electrons carry a negative charge and they're zooming around. And so it's really hard. They're constantly moving, they're constantly in motion. So to know where they are and how fast they're going at any given time is kind of complicated. So we have protons and neutrons in the nucleus, the center of the atom, and we have electrons, I'm just going to put the abbreviation, in the electron cloud. And the electron cloud is an area, so it's an area around the nucleus. And so these electrons are constantly in motion. And the electrons control how atoms chemically combine. And then the nucleus determines whether or not you're going to have radioactivity. So we've got our three subatomic particles. Now we need to kind of talk about their properties. So how does the mass of a proton compare to the mass of a neutron? Well, both protons and neutrons are found in the nucleus. Those are our heavy particles. So the mass of a proton is approximately equal to the mass of a neutron. They're about the same. But how about that electron? How does that electron compare to either a proton or a neutron? It doesn't matter. So it's fractional. It's tiny. So the mass of an electron is actually about 2,000 times smaller than a proton or a neutron, either way, however you want to think about it, right? So much smaller and different charge, right? So you have to understand the charges, you have to understand the masses. So how do we describe the units? Like, do we use grams when we talk about protons and neutrons? No, we don't. We talk about them in terms of an atomic mass unit. So all the masses on the periodic table are not in grams, they're in atomic mass units, or AMU, right? AMU. Okay, so now you have to understand the periodic table to be able to derive lots and lots of information about it. So I want you to have open, oops, I did not want to do that. I want you to have open your exam resources, and I'm going to put mine like right next door, right? So you want to open your exam resources and you want to have it ready to go. So let's look at any given atom. So I'm going to pick to look at oxygen, right? So I see three different things inside oxygen's box. The first thing that I see is the 8 at the top. So what does that 8 at the top mean? That 8 at the top is called the atomic number. So when you think about atomic number, this is what makes an atom of oxygen, or an atom of hydrogen, or an atom of helium. What makes it unique? and that is the number of protons. So the atomic number is also the number of protons in the atom. Okay, so that's a really big, really important piece of information there. What else can you derive from that square? Well, if I look here, I have this number 16. This is my atomic mass. My atomic mass is a measurement of how much mass was the average. It's really the average mass of all the atoms of oxygen. Now, all the atoms of oxygen are not quite the same. Some of them weigh a little bit more than others because they have different numbers of neutrons. So that's why it's not a whole number. That's why we go, to, let's say over here, phosphorus, right? We have 30.97. It's not a whole number because it's an average. But okay, let's go back to oxygen. So our atomic mass and the units on that are AMUs, right? That's what we were just kind of talking about. Okay, so what can be determined from the following? Well, we have atomic number, we have atomic mass, but there's another term that we have to worry about. And that term is it's the first one, the mass number. So the mass number is not on the periodic table, right? So the mass number is another number that's not here on the periodic table, mass number. And we don't put it on the periodic table because the periodic table is kind of like all of the possibilities for oxygen. So a lot of times when we talk about a specific atom, we have to give a scientific notation for that specific atom. So let's say that I had oxygen, and I know oxygen has 8 protons. No matter what, every single element, every single atom of the element oxygen has 8 protons. So when I write the symbolic notation of this particular atom, I put that 8 that I found right here, and I put it at the bottom. And then at the top, I give what's called a mass number. And I'm going to tell you, for this particular atom of oxygen, I have a mass number of 12. So what is a mass number really? The mass number is equal to the number of protons plus the number of neutrons. Well, that kind of helps me out. Let's see if I can derive some more information from this, right? So if I know my mass number, that means I know how many total protons and neutrons there are. And if I know down here my atomic number, then I know here the number of protons. So if I know both my mass number and my atomic number, all I have to do is subtract the two, mass number, and it's kind of lined up. I love it because I just draw a line. Watch. This is not part of the notation. I just draw a line and a little subtraction sign. And so if I take my mass number minus my atomic number, I'm going to get my number of neutrons, right? That's pretty cool. So you get number of neutrons. I know what that is. So 12 minus 8 is 4. So I know I have 4 neutrons. That's kind of cool, right? Okay, so let's go, what were our questions? What can be determined from the following? The mass number. So what does the mass number tell us? The mass number tells us, I guess I don't need that right now, tells us the number of protons and the number of neutrons. And you think about that mass number. What are the number of subatomic particles that take up mass? Well, which ones are the most massive in the cell? The protons and the neutrons. So those are the ones that give you a mass number. So this is always going to be a counting number. It's always going to be a whole number. The atomic number is, again, always going to be a whole number because this number is simply our number of protons. Okay. And then if we take the mass number, which we said was right here, minus the atomic number, what does that give us? That gives us the number of neutrons. And this is, again, a whole number, right? It's not a mathematical calculation. It's just, you're just kind of counting, right? So it's always going to be a whole number. All right. Provide the name and atomic symbol of the element that has the following atomic number. What is atomic number? Atomic number is always going to be number of protons. And when we look in the periodic table, I want you to use your periodic table. This little number at the top, right there, I'm circling for all of them, that is your atomic number. So let's go and find on this periodic table the elements that have these particular atomic numbers. So if we look for 79, so you know they kind of go in order, right? So here, ooh, stay still, right here, ooh, if I can do this, is 79. So 79, the symbol is AU. And remember how I said there were some that were based on their Latin names? This is one of them. So AU is gold. AU is gold. Okay, let's do the next one. 19, 19. Okay, so kind of zoom out and I want you to go look for 19. So here's 19. 19 is K. So we're just going to put K, and K is another one of those Latin ones. It is potassium. Potassium. Okay. So then 82. This is really easy. So when you're looking for 82, right? Let's see. I was cutting it off right here. Ooh. Here's 82. 82 is PB. It's not peanut butter. PB. PB is actually lead, right? Another one of those Latin names. Why do they have to keep doing that to us? Okay, 33. 33 is AS. AS, and AS is arsenic. ARSENIC, arsenic. And then the last one is number 11. Number 11 is sodium. Another one of those Latin ones. Oh, they had to do so many of those, right? Sodium. So that's all you had to do. Find the correct element, symbol, and name. Okay, so let's kind of hide that. All right, what is the mass number of a fluorine atom that contains 10 neutrons? So fluorine is going to be the symbol F, and we know that it contains 10 neutrons. Okay, so go back to your periodic table, and we want to find fluorine. So here's fluorine. So what can we tell just from here? Just from the periodic table? Well, we see this 9, right? What does that 9 mean? That 9 means that's the atomic number, and the atomic number is the number of protons, right? Protons. So when we write the symbolic notation, we're going to put the 9 down here. Now, we know that we have 9 protons, and we know, so I'm going to put a comma, 9 protons. We know that we have 10 neutrons. So from that, we can take the number of neutrons plus the number of protons and get the mass number. So the mass number is just the addition of these two. So the mass number is 19. So then you would say mass number is equal to 19. And to put it into the symbolic notation, you put the 19 at top and you put the 9 at the bottom. Okay. All right. So determine the number of protons, neutrons, and electrons in the following atoms. Okay, a helium atom. Got to go find helium right here. Ooh. Okay, so this is helium. It's the one we're going to look at. Let's see if we can make. Yeah, there we go. Okay, now we're rocking and rolling. So a helium atom that has a mass number of 4. I want to know protons plus neutrons and electrons. Okay, so we're doing this for how many? It's just 2. Okay, so this is going to be A and this is going to be B. All right, so we have helium. A is helium and carbon. B is carbon. Okay, so we said helium has a mass number of 4. I'm going to put that symbol right there at the top. It's a 4. And then I know over here that helium has an atomic number of 2. So I'm going to put it there. So with that symbol, I can answer everything. So my number of protons, I know that that's my atomic number. So that's a 2. Now, in a neutral atom, you always, always, always have the same number of positive charges as negative charges. That's a neutral atom. Positive equal to negative. So if I have 2 positively charged protons, I must have two negatively charged electrons. So I'm just going to go ahead and put that. And then my number of neutrons, all I do is take my mass number minus my atomic number. So I subtract the 2, I get 2. That tells me how many neutrons I have. Let's do the same thing in B. We're doing carbon that has a mass number of 14. So let me kind of erase this. So I want to do, let's do a different color. Let's do red. So I have carbon 14. So if I go look for carbon, there's carbon 14. So no matter what atom it is, what isotope of carbon it is, I'm always going to have 6 protons. Otherwise, it's not carbon. So I can put my 6 right there. And I know it's neutral, right? So I can go ahead and put my 6 there for number of electrons. Now, number of neutrons, 14 minus 6 is 8. So that's my number of neutrons. You just got to do more practice. Write the symbolic notation for atoms with. Well, we've already been working on this. This is so awesome. We can do this, right? No big deal. Okay, so let's do A. Let's see. A, we got 3 protons and we have 4 neutrons. Okay, so I'm going to go to the periodic table. I'm going to go find who has 3 protons. If I look for number 3, that is lithium. Let me erase all this. Okay, so there's my 3. So then I have lithium. And I know that number of protons is going to go down at the bottom. And then I know that at the top is my mass number. So my mass number is my number of protons plus my number of neutrons. So 3 plus 4 is 7. Okay, let's try another one. B, 7 protons, come over here, 7 protons, right there is nitrogen. So I'm going to put the symbol in. Nitrogen is always going to have 7 protons, so that's always going to go there at the bottom. And it's telling me I have 10 neutrons. So my protons plus my neutrons gives me my mass number. So 7 plus 10, 17. Keep going, keep going. Okay, 15. So 12, went the wrong way. Okay. Oh, there we go. You got to tap the other side. I got to get in the habit of doing that. There's 15. So this one is phosphorus, and phosphorus has 15 protons. We said that right here, right? And 16 neutrons. So I have to add the 15 and the 16. I get 31, and that is my symbolic notation. It's really, you gotta love this. Makes it really easy. 46. Oh, we're gonna jump all the way up here to 46. 46 is PD. Ooh, palladium. So we have 46 protons. I did that too close, didn't I? And then what goes at the top is our mass number. Our mass number is protons plus neutrons. So 46 plus 60, we get 106. Okay, pretty good stuff. Last one. Determine the number of protons, neutrons, and electrons for each of the following. So I'm going to kind of make a grid, right? Kind of keep them separate. And what we're looking for here is to determine the number of, well, let's do one across the top. Protons, neutrons, and electrons. Okay. Now we're cooking with fire. Okay. So H is hydrogen. So I know that I have 1 proton because that is my atomic number right there. And I know it's a neutral atom because I don't see a positive or negative anywhere. So I have 1 electron. My number of neutrons is our mass number, right there, the 2, minus our atomic number, which is the 1. So I know 2 minus 1 is 1. So it's just a little subtraction, and it's already set up for you. It's so nice. Okay, protons is 13. I know they're going to be equal electrons, so I'm going to go ahead and put that. Then I know this here is my mass number, right? Same thing up here, that's my mass number. So I take my mass number minus my atomic number. So 27 minus 13, we're going to get 14, and that gives us our number of neutrons, okay? Sodium. atomic number of 11. So that tells us we have 11 protons. It's neutral, so we must have 11 electrons. So then our mass number of 23 minus our atomic number of 11 gives us 12. So we have 12 neutrons. Bromine, we're saying this has an atomic number of 35. So that gives us 35 protons. It's not positive or negative. So we have 35 electrons. And then we look at our neutrons, and our neutrons are 79 minus 35, which give us 44 neutrons. Okay, I think, yep, that is the end of section 2. Yay! All right, see you next time.